Hello friends and welcome back to your channel GATEquestionsECE. I am back with the next question on the series of random variables and the question code is 110. If continuous random variable z, x1 and x2 are related by z is equal to minimum x1, x2 where x1 and x2 are independent random variables, then which of the following statement is true for the PDF of z? So out of these four statements, only one statement is true. We will have to find out which statement is true. So let's see how to solve this question. To solve this question, we will use the conclusion from question number 107 that we have solved earlier. So the end result of question number 107 was that if z is minimum x1, x2, then the CDF of z will be equal to sum of marginal CDFs of x1 and x2 minus the joint CDF of x1 and x2 calculated for same sample value all that. We know that the PDF of any continuous random variable is equal to the differentiation of its CDF. So simply by differentiating both sides with respect to z, we can obtain the PDF of z. So differentiating both sides with respect to z, we get f capital Z small z. So its differentiation, the CDF's differentiation is its PDF. Similarly, its differentiation will give us its PDF. And since x1 and x2 are independent, so we can write this as product of marginal CDFs. So differentiating this, we will get capital F x1 z into PDF of x2 plus PDF of x1 into CDF of x2. So this is the PDF of z. So the correct option is option 2. Similarly, if in question it's given that z is minimum among three random variables x1, x2 and x3 where all the three random variables are continuous random variables, we know that its CDF is given by the sum of three marginal CDFs minus three combinations of joint CDFs of x1, x2, x3. So these are the possible combinations. So the joint CDFs plus the joint CDF of all three random variables Moreover, if it is given that x1, x2, x3 are mutually independent, then we can write that these joint CDFs will be the product of marginal CDFs of x1, x2, x3. So in case x1, x2, x3 are mutually independent, then the capital F Z CDF of Z will be the sum of three marginal CDFs minus product of marginal CDFs of x1, x2 minus marginal CDFs of x2 and x3 minus marginal CDF of x3, x1 plus the last term product of three marginal CDFs. So now to get the PDF of z, you can simply differentiate on both sides of this equation and get the PDF of z. So differentiating both sides, we get that f capital Z, sample value small z, will be equal to the sum of PDFs of x1, x2, marginal PDFs x1, x2, x3 minus differentiating this, we will get similarly for this term. I am simply writing, I am dropping this z, and for this term differentiating we get CDF of x3 and PDF of x1 plus PDF of x3 and CDF of x1, and last term differentiating this term we will get CDF of x1, CDF of x2 and PDF of x3 plus CDF of x1, PDF of x2 and CDF of x3 plus PDF of x1, CDF of x2 and CDF of x3. So this is the PDF for Z, where Z is minimum among x1, x2 and x3, and x1, x2, x3 are continuous and independent random variables. See, I have calculated here for 2 and 3 random variables. In similar way, you can calculate for any number of random variables. You can calculate the PDF of Z. So I hope you are learning and enjoying this series on random variables. And in future, I will be bringing to you numericals which are based on these formulas. So keep watching this video series and do press that like button below this video and subscribe to my channel for more such videos in future. So thank you for watching this video. I'll be back with new video soon.